In this video, I'm going to talk about kinematic equations and solving problems. This video will not cover free fall problems, but I'll do that in a later video. On a board are the 4 kinematic equations you need to know to solve for unknown variables. You must understand that acceleration must be constant for these types of problems. Quickly jot down these 4 kinematic equations and we'll get into an example. In this problem, we are told that a car goes from 0 to some velocity in 10 seconds, and we are told the acceleration of the car is 6 meters per second squared. We are asked, what is the final velocity of the car? Before solving problems, I like to jot down my given variables, then see which kinematic equation fits best. So in this problem, we are told that the initial velocity is 0 meters per second. We are told the time is 10 seconds. And we are told the acceleration is 6 meters per second squared. Now that we know our given variables, let's see which kinematic equation fits best. After looking, we see that the first kinematic equation fits best, so let's plug in our values. So our final velocity, which we don't know, equals our initial velocity, which is 0 meters per second, plus our acceleration, which is 6 meters per second squared, times our time, which is 10 seconds. This will give us a total of 60 meters per second for our final velocity. In this problem, we have a walker that maintains a constant velocity of 5 meters per second and travels 70 meters to the right in 10 seconds. And we are asked, what is the acceleration of the walker? Like we did before, let's jot down the given variables. So we know that our walker's initial velocity is 5 meters per second, since the walker maintained a constant velocity of 5 meters per second. And we know that our displacement is 70 meters, and the time is 10 seconds. Now let's look at our kinematic equations and decide which one is best for this problem. After looking, we know that the second kinematic equation fits best for this problem. So let's plug in our values. So our displacement is 70 meters, and that equals our initial velocity, which is 5 meters per second, times our time, which is 10 seconds, plus 1/2 times our acceleration, which we are trying to solve, times our time squared, so we get 10 seconds squared. And now let's simplify. So we get 70 meters equal 50 meters plus 50 seconds squared times our acceleration. Let's subtract each side by 50 meters. After doing so, we get 20 meters equal 50 seconds squared times our acceleration. Now let's divide each side by 50 seconds squared. This will give us our acceleration, which is 2/5 meters per second squared. In this problem, we are told that a train goes from 0 to 60 meters per second to the left and has an acceleration of -15 meters per second squared. So we know that our initial velocity is 0 meters per second. We know our final velocity is -60 meters per second since we're going to the left. And our acceleration is -15 meters per second squared. Now looking at the kinematic equations, let's see which one fits best for our problem. So the best one that fits for our problem is the third one. So let's plug in our values. So our final velocity is -60 meters per second. And we're just going to square this, which equals our initial velocity, which is 0 meters per second, plus 2 times our acceleration, so 2 times negative 15 meters per second squared, times our displacement. So let's solve. On the left side, we will get 3,600 meters squared per second squared, which equals negative 30 meters per second squared times our displacement. So let's isolate our displacement term. And to do that, we divide each side by negative 30 meters per second squared. This will give us our displacement, which is negative 120 meters. For our last problem, we are told the van goes from 0 to 10 meters per second and travels 5 meters. And we are asked, how long did it take for the van to travel 5 meters? Like we did in our previous problems, let's first jot down the given variables. So we know that our initial velocity equals 0 meters per second, and our final velocity equals 10 meters per second. We also know our displacement equals 5 meters. Now looking at our kinematic equations, which one best fits for our problem? After looking, we can see that the fourth kinematic equation best fits for our problem. So now we can plug in our values. So we have our final position minus our initial position, which is the same thing as our displacement. And we know that displacement equals 5 meters. So on the left side of the equation, we have 5 meters, and that equals 1/2 times our final velocity, which is 10 meters per second, plus our initial velocity, which is 0 meters per second, times our time. We can multiply each side by 2 so that we got 10 meters equal 10 meters per second times time. And we can divide each side by 10 meters per second, which will give us our time to equal 1 second. So in recap, kinematic equations can only be used if our acceleration maintains constant. Thank you for watching this video and hope to see you next time.